20-1s. We get to solve some more equations. We've done a lot of equation solving in this particular course, and we add one more type, and that's absolute value equations. So obviously an absolute value equation is at some point going to have absolute value in there. And we'll have an equation, equal sign, left side, right side. And we're going to need to figure out what values of x balance an equation. Nothing's new in terms of what we're trying to do. We need to know what x is so that this left side is exactly the same as the right side. So let's just jump into it. What I do find is that the math is fairly straightforward. There is one real important trick or thing that consider not a trick but something to remember with absolute value equations, but the algebra is a little more straightforward than some of the other stuff. But that thing you have to remember is that you have to always solve absolute value equations twice. There isn't going to be one answer only at times. Because if we look at a really simple, straight up absolute value equation, the absolute value of x equals 7. Well, what does x equal? Well, x could equal 7. Because if I substituted 7 in, what's the absolute value of 7? It's 7. However, we also realize, or hopefully understand, what else could x equal? What could I put for x that will equal 7 besides a 7? Well, x could equal -7 as well, because the absolute of -7 is also 7. So we have to understand that what this x equals could be the positive or the negative of it, because a negative of whatever's in there will equal 7. So if we take a look at what's beside here, a little bit more involved, we know that to get an answer of 5, our y plus 4x could equal positive 5. If this all equaled 5, well, the absolute of 5 is 5. However, what else could y plus 4x equal? Well, if I got my y plus 4x to equal a -5, what's the absolute of -5? Well, it's also 5. So what I have in the absolute brackets, I don't want this y plus 4x to only equal 5. This y plus 4x could also have a value of -5. Because if this equaled -5, the absolutes turn that -5 into a positive 5. So anytime we go to solve absolute value equations, we have to solve twice, because what's inside the absolutes could equal the positive of what we're trying to get, but what's inside the absolutes could also equal the negative of what we're trying to get. Because -5, if this y plus 4x equaled -5, that would still be okay, because the -5 would turn to a positive 5. So we are always solving twice. We're solving for the positive and the negative of the equation. So that's the trick with absolute value equations. So page 10. Here's probably about as easy a question as you're going to get. X plus 3 absoluted is equal to 7. Well, like we just talked about, the first thing these questions require is you want to isolate the absolute sign on one side. We have that. X plus 3 is by itself on one side in the absolute. But now we have to solve twice, because x plus 3 If that equaled 7, that would be good, because the absolute of 7 is 7. So that's all right. But what else could x plus 3 equal? If x plus 3 in the absolute equaled negative 7, we'd still be happy, because the absolute of that negative 7 would equal 7. So our x plus 3 could also be the negative of what we're trying to find. That's the trick. You're going to have to do 2 algebra questions for each. If I solve, subtract 3 from both sides, x is equal to 4. Here, subtract 3 if I solve this one, and x would equal negative 10. So we solved twice. And now, as with all of these situations we've talked about, sometimes we're going to get extraneous answers. These unique situations, whether it's radicals or rationals or now absolutes, they're unique situations that sometimes you get things that don't work. So we always have to verify. First one, x plus 3, absolute equals 7. Well, we think x could be 4. 4 plus 3, we want to equal 7. Well, like we talked about first lesson, the absolute value sign, do what's inside first. Absolute of 7 equals 7. That's true. So we're okay. X equals 4 is correct. But the second time, the absolute this time of x plus 3, we now think x could be negative 10. So negative 10 plus 3, we think, remember, we're always verifying the original, so we think x equal to negative 10 is a solution for the original. We always verify the original. And negative 10 plus 3, well, we have the absolute of negative 7, and the absolute of negative 7 is 7. So yes, 7 equals 7. We have 2 solutions because there's 2 values we can plug in for x that when the work is done in the absolutes, we get a value of 7. So you have to solve twice. So let's continue. Next one, page 10. Same kind of process, but now a little bit uglier. First step is to isolate the absolute. So we're going to subtract 1 from both sides. And we talked about in that first lesson, a number beside the absolute is like multiplying, so we can divide by 2 to eliminate it. And we have the absolute of 7x minus 1 equals 5. So a couple steps just to get to the form we need. From there, well, now we have to solve twice, because our 7x minus 1, it would be good if that equaled 5, because the absolute of 5 is 5. So we want to solve and get 7x minus 1 equal to 5. We also realize, hopefully, that this 7x minus 1, if it had a value of negative 5, the absolute of negative 5 is still our 5. So we would be okay if 7x minus 1 equaled negative 5. We need to identify the 2 situations, because one could be positive, one could be negative. So algebra to solve. 7x equals 6. Divide by 7. And x equals 6/7. The other possibility, add 1. 7x equals negative 4. Divide by 7. And x could equal negative 4/7. So we have 2 possibilities, 6/7 and negative 4/7. Well, again, verify. Always finish with verifying. Our original question was 2 absolute 7 times x, which we now think could be 6/7, minus 1 plus 1 equal 11. do what's in the brackets first. 7 times 6/7, 7 over 1 is a 6. 6 minus 1 is a 5. So we have 2 absolute 5 plus 1, 10, because it's 2 times 5 now, plus 1, 11 equals 11. Left side equals right side, so x could be 6/7. Well, we need to verify as well our second possible answer. So verify again, always, like we just did, verifying the original. We're assuming our x works in the original. 2 absolute, 7 times -4/7 minus 1 absolute plus 1 equals 11 is what we're hoping. Brackets first. 7 over 1, we can cancel 7s. We get -4 minus 1. We get 2 absolute -5 plus 1. Well, absolute beside a number is like saying 2 times, and the absolute of -5 is +5 plus 1. 2 times 5 is 10, plus 1 is 11. And 11 equals 11. Left side equals right side again. So, 2 solutions, 2 possibilities, because what we have inside of our absolute could be +5 or -5, and we need to solve for both of those situations. So, let's take a look at another one. Let's go to page 11. Same idea. You might want to give this one a try on your own. Stop the video, see what you come up with. Process isn't overly complicated, but you have to remember we're solving twice. All right, some of you may have gone and done it, some of you might not have, but here we go. So the first thing, isolate your absolute. Subtract 9, so we're left with absolute of 5x minus 4 equals -7. Well, what are we going to do here? I'll be honest with you, we're not going to do anything. You need to learn to recognize a situation like this. What's the problem? The problem is we have the absolute of something, and we're saying the absolute of some value equals -7. That's not possible. In this case, what we have is the absolute of anything has to be the positive. And since our absolute equals negative, this question is not possible for a solution. So, got to think sometimes. I know it hurts a little bit, but you got to think. Page 13. Let's take a look at this one. Page 13, it's not a lot different, except the question becomes, now we have a quadratic instead of linear. Same process, just a little bit more work. So we're still, step 1, isolating the radical on one side. Step 2, we have to solve twice. Why? Because everything that's in the radical could equal 6. If this had a value of 6, the absolute value of 6 is 6. That's a good thing. So we know we have to solve x squared plus 10x plus 15. We want to equal 6. But what's that other possibility? Well, the second possibility is if our x squared plus 10x plus 15 were to give us a value of -6, we'd still be happy with that -6 because the absolute of -6 is +6. So our second equation would be x squared plus 10x plus 15 equals -6. 2 equations to solve. Solving quadratics. Oh, I know it was a long time ago. To solve a quadratic, everything goes to one side, so we have equals 0. And then we can factor. That's how we solve quadratics. So we're going to subtract 6. We're left with x squared plus 10x plus 9 equals 0. And we factor. Well, when we factor, this could be multiply to 9, add to 10, positive 9, and a positive 1. So if that's the situation, our x could be negative 9 or negative 1, because in this case, we would want one of these to be 0, and this becomes 0 if x is negative 9. This becomes 0 if x is negative 1. There's two potential answers. But I have to solve the second one as well. X squared plus 10x plus 15 minus 6. Add 6 to both sides. X squared plus 10x plus 21 equals 0. Again, a nice simple trinomial. Multiply to 21, add to 10. X plus 7, x plus 3. So if x were negative 7, it would give us a 0, which is what we're looking for. Or if x was negative 3, it would give us 0. So we potentially have 4 answers this time, which means we have to do 4 verifications. You really do. You have to make sure there isn't an extraneous answer. So very quickly, here we go. X squared plus 10x plus 15 equals 6. And then we're going to have to do it again. X squared plus 10x plus 15 equals 6. And then we're going to have to do it again. X squared plus 10x plus 15 equals 6. And then the absolute of x squared plus 10x plus 15 equals 6. First time, we thought x was negative 9. So negative 9 squared plus 10 times negative 9 plus 15. Well, we get 81, negative 90, and 15. 81, negative 90, 15. There's a value of absolute value 6 equals 6. Left side equals right side. One answer is correct. Next answer we had was negative 1 potentially. So negative 1 squared plus 10 times negative 1 plus 15, all in absolute. 1 plus, I guess, or minus negative 10. Minus 10, because it's a negative 10, plus 15. Combine all that stuff up, and what do we get? We get absolute of 6, which equals 6. Left side equals right side. We have a second correct answer. Third time, we thought it might be negative 3. So, is that true? Here we go. Negative 3 squared plus 10 times negative 3 plus 15 equals 6. Absolute 9 minus 30 plus 15. Add all that up. What do we get? We get the absolute of negative 6. But that's okay, because the absolute of negative 6, 6 equals 6 still. Left side equals right side. X equals negative 3 is a correct answer. And the last verification is x negative 7. Negative 7 squared plus 10 times negative 7 plus 15 equals 6. 49 minus 70 plus 15. Add that stuff up. What do we get? 54. 64 minus 70 is a negative 6. And again, absolute of negative 6 is 6. That equals 6. Left side equals right side for a fourth time. So we have 4 solutions. All 4 verify, nothing extraneous. Solving twice. When you have a quadratic and you have to solve it twice, you get 4 answers. All right, so there's a couple different situations, whether it's a linear or whether it's quadrilateral. Sorry, not quadrilateral. I was just thinking of a different course. If it's linear or if it's a quadratic, we can solve, but we always have to solve twice. Now, what's interesting is, like a lot of the other equation work we've done, we can do this graphically on our calculators. However, Please again understand, the word algebraic means you need to show your steps. Anytime a question says solve algebraically, you need to show the work we just did on these other questions. You need to show two separate equations and the process of solving. That's algebraically. But you can do it graphically, which is always a great way to check. Graphically, you know what? You do it algebraically, graphically you can check your answer. See if it is correct. And what's nice graphically, it's really no different than what we've done before. Very quickly to review the steps, what do we want to do? Graphically, we have to create the equation, move everything to one side so it's y equals. Because remember, we're going to put it into the y equals, and it says y equals, I need everything on one side so that it's an equation with equals 0. We then punch it into the y equals feature. Now a little bit different is if you want to input an absolute sign, well, you're going to hit the math button, and on the top of your display, and we'll take a look at it, you want to scroll to the right once, so you highlight number, which will then give you the option to choose one absolute, and when you hit that, a set of absolute brackets will show up and you can punch inside of that. Once you've input your equation, you graph it like we did, and we're still doing second trace, we want the zeros, and we follow the screen prompts to get them. So here we go. Let's take a look at a couple. Looking at page 11. There's the first question on page 11 that I want you to do. Actually, all three of them are there. Let's walk through one together, and then you can take a look. First thing, though, is we want to make sure we have an equation equal to 0. So I'm going to move so I have everything on the left side. So I would have my absolute, x minus 2, but when my 3x goes over, it becomes subtract 3x. My negative 14 goes over, becomes a positive 14. That'll equal 0. There's what I want to punch in on my calculator. So here we go on our calculators. Y equals, what are we inputting? All right, we're going to math. And along the top, math, number, complex, problem, whatever, we're going to scroll over so num is highlighted. And we see choose number 1, whether you go down to it with the scroll or you hit number 1 on the keypad. Now we see we have absolute brackets. And we want x minus 2 in there. So x minus 2. Make sure you scroll outside now because that's all that's inside the brackets. And our new equation was subtract 3x plus 14. There's our equation. Now we graph it. Now, what's nice with this is a couple things. Are we correct with our graph? We could make it bigger. We do see there's no squared, so our single x means it's linear. We're only gonna, it's a line with some bends because of the absolute, but we're not gonna have multiple roots or solutions. So there we go. What do we do next? Same as we did before with quadratic graph solutions. Second trace, we want the zeros. So the prompt says scroll so that we're on the left side of the 0 or the intersect. Scroll so we're on the right side of it. Hit enter and hit enter one more time to guess it. So our solution here is x equals 6. So we know with this x equals 6. There we go. Now, give the next two a try or follow along with me again. You might want to stop it, give them a try, and then rejoin. Second one, what we want to do, again, keep the absolute. We're happy with the 9 on that side, but the 2 needs to come over. So I'm subtracting 2. So instead of a plus 9, 9 minus 2 gives me plus 7. That equals 0. There's what I want to substitute in for the brackets. Now, some of you might recognize that we just solved this one earlier. So let's see if what we said, no solution, is correct when we graph it. Go to the calculator, y equals, let's clear what we had. And again, math. Scroll over so the number is highlighted. We want the absolute number 1. What are we going to put in this time? 5x minus 4. Leave the absolute. Whoops. Leave your absolute. What happened there? Let's try that again. Something went wrong on me. Scroll over. We want, so we have 5x minus 4. I want to leave the absolute sign, and then we had plus 7, and we're going to graph that. Now, don't see a lot of the graph. I'm going to just change my window. My y max, I can go up a little bit to see what happens. And when I graph that, well, I see that my graph doesn't have an intersection point. There is no x value, which matches what we found out when we solved algebraically. There is no solution. Algebraically it worked out. Graphically, we got the same answer. Impossible, no solution. Last one, a little trickier because there's some more brackets and things. However, does that matter? Not really, because if I move everything to one side, the 2x comes over to be a negative 2x. The 8 comes over to be a negative 8. That all equals 0. And now I can graph that. So again, here we go. Lots to be graphed. Y equals, clear what we had. We have 2. Now I need my brackets. Math, scroll over to number. We want number 1, the absolute. We're going to put 2x minus 6 in there. Leave the absolute. Please don't forget that. Subtract 2x, and then subtract 8. Let's graph it and see what we got. Now, I can't see the whole graph. However, I can see the points of intersection on the y or x-axis, which are my roots, my solutions. 2 of them, so I need to get the solution twice. Second trace, choose the 0, scroll, so I'm going to do the left intersection first. And from there, I hit enter, go to the right side, hit enter, and hit enter one more time. We get a value of x decimal 66667, which is the same as 2/3. There's one answer, 2/3. We need to do a second trace a second time. We want a 0 because now we want the second solution. Scroll over so we're on the left side of the intercept, enter, get to the right side of it, enter, yes, please guess it, and we get an x root value solution of 10. So in this case, we get x equal to 2/3 and positive 10. Graphing solutions, possible, nice way to be able to check if you choose. Very quickly, I want to take a look on page 12 because they do it a second way as well. Sometimes when you have bigger, there's other ways to do it graphically. Rather than move everything to one side, you will sometimes see resources use the left side and the right side of the equation as your y1, y2 graphs. So we're going to end up with 2 graphs if we graph these. And just like last year with systems of equations in the grade 10 course, remember in grade 10 when you had 2 lines and you wanted to know what the solution was? Where they intersected was your solution. Well, it's the exact same thing with this. I'm inputting 2 graphs, technically the left side and then the right side, and the intersection points are the solutions. Same idea, but now we're going to go second trace and choose the intersect points. Same basic idea. don't have to manipulate to start with to get everything on one side, because the left side and the right side are what I'm putting in. So y equals, clear what we had for that first one. Here we go. We need the absolute. And the first one is x minus 5. I need to leave that. And I want plus. I need a second absolute. And the second one has 6x plus 2 in it. Leave that. There's our first line, our first graph. And the second graph, the right side is just 33, which will just be a straight horizontal line at 33. So we want to graph those two things. Now, we don't see two of them, but like I just said, when we have a graph y equals 33, that's just a horizontal line at 33. So we need to change our settings, and our y max needs to go up. I'll go to 40. And there's the two graphs. We can see the points of intersection. Those will be our solutions. Second trace. Now, though, because we don't want the 0, we don't want x equal or y equal to 0, we want the intersection points number 5. So again, that was second trace. We want the intersect points. What do the prompts say? First curve for first graph. Okay, we're on the blue graph. Hit enter. Second curve, it moves to it. Yes. Guess the solution. Please do. Now we're looking for the x values. That's what we're trying to solve for, x. So the y value I'm not really worried about, but our x is 5.14. There's one possible solution. Round to the hundredths place, and you can see in your booklet, this one actually has the answers, so you can verify if they're correct. 5.14. We need to get the second intersect point, though. So second trace, 5. Again, second trace, going to the intersect. Now we have to scroll to get there. I think there is a trick to get there quicker, but I forget what it is, to be honest with you. So we're on the left side of the intersect point, or on the first graph. We're on the second graph. Yes, please guess the answer. And the second x value, because that's what we're looking for, we're looking for x values, is negative 4.29 when it's rounded. So there you go. There's the two solutions for this. X equals negative 4.29, and it also equaled 5.14. You can try these other two if you want. The solutions for them, well, we see that the solutions here, x would be negative 1 and 7 1/3. And the next one, to give that one a try, a little bit different. Here, x works out to be negative 2 and 8. You can give those a try. So, graphically solving, if it says algebraically, the graphing knowledge is helpful to do a check. That's why it's beneficial. Algebraically, you got to solve twice. Remember that. Otherwise, I don't think it's too bad. There's your assignment out of the textbook. Stay on top of it. We're halfway through this unit. It's a quick unit. Absolute values, all that piecewise stuff, and now solving. Get the assignment done, get some practice in. Have fun.